Hey guys, so this video is going to focus on how do we find the domain when given an equation, specifically a rational expression equation. So if your equation has a lot of fractions, like the two examples that I have here, so this is what's called a rational expression equation. So we're going to be talking about how do we find the domain of these kinds of equations. So the domain is the range of all the x values that pertain to that equation. Almost always is your domain going to be negative infinity to positive infinity for most equations, except in a couple of special circumstances, rational expressions being one of those. So because rational expressions are pretty much fractions, what we should hopefully know about fractions is that fractions are undefined when the denominator equals 0. So if you have 0 in the denominator, that's what's going to throw that fraction off. And the same thing's going to pertain to when you have a rational equation that has a lot of fractions in it. Same thing applies here. If these denominators were to equal 0, it would throw these equations off. So if we were to graph these, essentially, so let's just pretend this happened to graph into a nice pretty line here. The domain is going to have certain holes in the graph where your denominator equals 0. So that's what it does to it. You're going to have these breaks in your equation. And what we're trying to figure out is where are those breaks? What essentially is going to make these rational expressions undefined, because where those are undefined, it's going to give us holes in our equation. It's going to give us holes in our graph. So that's what we're looking for here, is where are those holes, or does our equation have any holes first, and then where are those? So when it comes to rational expressions, the main thing you need to focus on is the denominator, and specifically what makes the denominator equal 0. So we're going to start with example A. So starting with example A, I want you to take a look at every single denominator that you have in the equation. So we have the denominator of x plus 6 right over here, and then we have the denominator x minus 7. So we're going to focus on those two there. And essentially to find the domain of this equation is going to be negative infinity to positive infinity, except where these denominators equal 0. So in order to find that, we're going to take the denominators in our equation. So again, that is x plus 6. And that is x minus 7. And what we're going to do is we're going to take those denominators, set them equal to 0, and solve those little mini equations. Now these are little one-step equations. For the first one, all we have to do is move that 6 over to the other side, so we subtract it to both sides, giving us that x is equal to negative 6. And then for the second one, the x minus 7, we do the opposite of minus 7, and we plus 7 on both sides to give us that x is equal to 7. What that tells me is that on our x-axis here, on a negative 6, on a positive 7, we're going to have holes at those two spots. So our domain, our range of all of our x values is negative infinity to positive infinity, except for negative 6 and 7. So what we're going to do is we're going to write our domain like this. So we're going to open up our set here, and we're going to say that our domain is equal to all x values, so this pertains to every single x value in your coordinate plane, such that x does not equal negative 6 and 7. So this is what your domain is going to look like here. It just says it's every single x value except for negative 6 and 7, since that's what's going to make our denominators equal 0, and it's going to throw it off at those two values. Everything else is good. So we're going to do the same exact thing for the second equation. So again, we're only looking at our denominators for this kind of problem. We really don't care what's going on with the rest of the equation for right now. If all we need to do is give the domain of it, and this is a rational expression, look at the denominator. So our first denominator we have is a 3x plus 4. Then we have an x, and then we have a 5x minus 1. We're going to set each one of these equal to 0 and solve. Starting with the first one, 3x plus 4, we're going to minus that 4 on both sides, giving us 3x is equal to negative 4. And then we're going to divide out that coefficient on both sides, giving us that x is equal to a negative 4/3. With the second one here, our denominator was x. We set it equal to 0. There's actually no solving going on with that one. We get x equals 0, so that means we are going to have a hole at 0. And then for our third one here, we're going to start by adding 1 on both sides, giving us 5x is equal to 1. Then divide out your coefficient, and that is going to give us that x is equal to 1/5. So again, the way that we're going to write our domain is all x values such that x does not equal -4/3, 0, and 1/5. Make sure you do write your answers in order from smallest to biggest. That's just proper form. They like to have it from smallest to biggest. But otherwise, with these kind of examples here, again, just set your denominators equal to 0 and solve, and those are going to be your holes in your domain. Otherwise, your domain is equal to everything else except for those numbers. Otherwise, that's it for this video.